Okay, I think we can start. It's time. So, my name is Alexander. I'm from IPRO Latvia. And first of all, I would like to say thank you all for coming to this section, today's great VMware event. So, I'm going to talk about network performance and security monitoring in your virtual environment today. So this is a very interesting topic, and feel free to ask questions. Feel free to come closer to hear me. Okay, let's start. As we migrate to VMware, we gain a lot of benefits. I'm not going to talk about them today. I think you know yourself most of them. What we'll talk about today are problems we have to solve. First of all, it's maintaining virtual network visibility. So you want your virtual network to be as transparent to you as your physical network. Yes, you want to know what is happening there. And the same is for assuring a sufficient level of security of your virtual network. So you do not want to lose your security when you virtualize your servers and workstations. So today I'm going to talk about one complete solution to help you solve both these problems. Okay, back in 2009, a company from the United States of America called Lenco introduced their flow sensor VE Virtual Edition. It was a major extension of the existing technology StealthWatch that allowed for flow-based network security and performance monitoring. So by that time, by 2009, this was an already major technology that was used in physical networks for 9 years, so since 2000. Okay, so StealthWatch is VMware ready, Cisco compatible. By the way, both these vendors also use StealthWatch in their networks. It's a publicly available information. Right now, StealthWatch is used in more than 500 organizations worldwide, and IPRO provides these services in Baltic region. So, here are the awards that StealthWatch receives on a regular basis. Okay, let's have a quick look into how StealthWatch works. So, this is a centralized solution to monitor your network and security performance. We collect flow data from physical devices like routers and switches, from VMware virtual switch, from network firewalls, to show you host-to-host communications. Here it's very important to understand that host in StealthWatch terminology is an IP device that is communicating on a network. It's not an EA6 host, so don't confuse these two terminologies. StealthWatch integrates with your different servers like LDAP servers, DHCP servers to gain user information. So you will know not only IP addresses but also usernames, and what is today becomes very actual is what smartphones, what laptops, what iPads are on your network right now and why they are there. So these are the basic functions of StealthWatch. I'm not going to talk much about each of them because it will take too much time. We're short of time today. And I just want to say that by design, StealthWatch allows you to see host-to-host communication with any host. It means that if you take two virtual machines on one physical SX server, you can see all the communications in between them. Why should you need this information? Well, first of all, when you migrate from a physical environment to virtual, you want to be sure that your servers behave at least the same, or not worse than they used to in physical environment. So what you get with StealthWatch is what I just mentioned. You see the impact of migration to VMware. Control host communications. As a pure security solution, StealthWatch has more than 100 unique algorithms to detect malicious activity. So you will see any host attempting to scam, flood, attack your network, or even if a workstation or a virtual machine is infected with a worm, you will see this. Okay, last 2 moments are you can control your network server, network and server performance with StealthWatch. You can do this using unique parameters, round trip time and server response time. It means that you see if you have a problem in your network, a user is calling you and saying, my application is working slowly. By going into StealthWatch Management Console, you can see whether it's network that's working slowly or the server that takes too much time to answer the incoming connection. And well, last but not least is you know which applications are running on your network, because StealthWatch uses application fingerprinting. It means that no one will be able to launch an FTP session on port 80 just because port 80 is open on your firewall without you knowing about it as a StealthWatch and security administrator. So this is also a very important thing. So we have a true application detection mechanism in our technology. So, okay, I'm going to show you a little demo, but before I would like to give word to our partner who is so kind to be visiting our event today. Please welcome Steve Simpson from Lemco. He is Director of International Sales.
Okay, well, Aleksander's covered the majority of it. I just want to reiterate, obviously, the main points, which are, as you start to virtualize, you start to lose that visibility into the network as it moves into a virtual network. Who now owns that? Is it still owned by the network people? Is it owned by the server team? Is it owned by the application team? Now, your applications change as well, because even though you're migrating over to a virtual environment, not necessarily all of the components of an application get migrated. So you can have a mixture of physical devices, so physical servers, and back-end systems and databases in the VM environment or in a cloud system, for example. So how do you control all of that? How do you gain visibility of what is going on in all of those environments? So what we're able to do, because we're getting the information from the physical network itself, and by putting these sensors into the VM environment on the VM ESX platform, we're able to provide you consistent visibility right across the entire estate. So we can show you the performance of the entire application and the security of that. Now, I think there's been a number of other sessions. I don't know how many of you went to the security sessions on how to secure your VM environment. But it is things such as having a virus spreading. So virus checking has an impact on that environment. Because we are using behavioral algorithms, we don't need a signature to determine whether or not there's a compromise in that environment. We can look at the performance, or we can look at the behavior of a specific VM, how it's communicating with other VMs inside that environment, to be able to provide you with that information. Now, as Aleksander said, we do have organizations like Cisco and VMware themselves who do actually use our technology in their own environments to be able to secure those. Cisco themselves are actually using this as part of their mobile monitoring solution. They've used it to secure events such as Cisco Live, the FIRST conference, which is a global CERT conference, and they will actually be using us in their mobile lab to monitor the traffic in at the Olympic Village in Cisco House during the Olympic Games.
Yeah.
So, yeah, absolutely. So, but just to give you a couple of examples of how this has been useful for organisations, the Graphisch Lyceum Rotterdam, so an education establishment in the Netherlands, they had a very large data center migration or server migration to migrate everything over to VM. And they had the same benefits argument to do that, to get the justification for spending all of that money. It was going to be faster, it was going to be more efficient, and they were going to be greener by migrating. So they had all the right, all the right ideas. But when they cut over and they migrated everything over, it was slow. They were having difficulty managing their applications, and they didn't understand why. Now, they had StealthWatch in their environment, so all they did was install the VM sensors, and they found that really all that was wrong was that they had too aggressively tuned the vMotion. And because we're vMotion aware as well, we could show them all the vMotioning happening, and that was the cause of the performance degradation. And once they got the tuning correct, they were able to prove that this was now actually faster, more efficient, and they maintained their security after they'd done the migration. So they're able to prove that. Now, it can also be used for compliance purposes, so PCI, SCADA environments, other health compliance and what have you. So, for example, there's a number of the very large online gambling organisations that are customers of ours. Now, those companies, by and large, their entire infrastructure is just one big virtualized data center. So they have their customers coming in to put bets on whether the next guy to score is going to be Rooney, and they have the customer's credit card details. Now, they were being told by the PCI auditors that they would have to create two completely separate infrastructures. One for the PCI systems or the PCI servers, and one for their application systems. But because we're able to monitor the VM to VM communications, and they can separate those in our system from a reporting point of view, they are able to prove that any system communicating from one VM in the application group to a VM in the PCI group will set off the alarms. They'll be able to show how it happened, when it happened, and how much data was transferred. So they got their PCI compliance without having to create completely separate infrastructures. Similarly, there's another one which we don't have here, but a customer of ours is Agence France Presse, so AFP in France. Now, they were actually originally evaluating us because they wanted to show that their content was getting to their customers as fast as possible, so performance requirement. So they were using our sensor to be able to show that response time, the round-trip time that Alexander was talking about. So they obviously need the newspapers and the news agencies to select their content instead of Bloomberg's and Reuters, so that was their main requirement, was performance. But while they were evaluating it, we were showing them that there was actually a Trojan in their network between Berlin and Toulouse. So they sent this information off to their security team, who said, no, we don't have a Trojan in our network. None of our systems are telling us that that's true. So they did a packet capture based on the systems that they knew were communicating this Trojan to each other. They sent it off to Symantec. Symantec wrote a signature for it, sent it back to them, and then they had a Trojan in their network. So we're able to provide you that security in the VM environment without having to use signatures, and without having to deploy any agents, and without having an impact on that environment. So by using this data, by using this information about host-to-host communication, you can ensure that you have not only a well-performing virtual environment, but that it's secure, and that you can see how your virtual environment is working alongside any physical environment that you still have. Okay, so I'm sure that Alexander will now show you all of that in the demonstration. On your way out, you can grab yourself a ticket for be able to download the electronic copy of one of these books, which will help you to understand how using flow data in your environment, whether it be the physical network or the virtual network, will be able to provide you with good security and good performance information in your environment. So thank you very much.
So, fortunately, resolution is rather small, but I think everyone can see. So what we have here is our connection to the United States, where we have a live stealth watch system monitoring part of Lankov's network. We have a lot of alarms here because Lankov guys usually create a lot of stuff themselves so that they have something to show to the customers in these live systems. So this is an example of a typical dashboard where you can see your infrastructure. Here we see a world map. You can put, for instance, a Lithuanian map here, put your headquarters in the center in Vilnius or Kaunas, and then all the branches if you have, and then connect them together. What you will see, usually you see in monitoring tools, you see a connection between switches. Stealth Watch looks at hosts, at physical hosts, at users. So we can logically group our assets into groups called host groups, everything that's inside our network and the internet. So here you can define some dangerous networks like botnet control centers, or for instance some Lithuanian special like social media, social like your local Facebooks, like we like to do in Latvia, or webmails. So just to monitor who is connecting there. So after you define these host groups, you can say that, for instance, no user from our network can go to our server using SSH connection. So they can use, for instance, port 80, port 443 for their own job, but they should not connect with SSH. They should not administer these servers because they are not IT administrators. So you define this with one rule, which is very like firewall rule. Yep. So this looks like a firewall rule. So for instance, a host from China should not connect to our DMZ except HTTP and HTTPS services, just like this. So one rule defines policy for your whole network, whether it's 100 hosts or 100,000 hosts. As I told in my presentation, we collect this data from your network devices. Switches, routers, firewalls, including VMware virtual switch, which is very important. Okay, next what we can see here is, of course, our virtual infrastructure. So Stealth Watch connects directly to the hypervisor, so it knows in real time the status of our virtual machines. And as Steve already told, we know all the vMotion events. We know when a new virtual machine is created. So if you are a security administrator or network administrator, you want to know when someone creates a virtual machine in your network, just like for, I don't know, for your own knowledge. Okay, next what we can see is identity services. Stealth Watch works very closely with Cisco devices, and especially with Cisco IC, Identity Services Engine. So Cisco IC is it's a control solution. Yes. So from Cisco IC we can know with information like which user at what time used which IP address where he resides right now, and his MAC address and his device type. So this is the place where you know whether it's an iPhone, iPad, or HTC, something else. You also see a port, connection port, which is very important when you want to troubleshoot a problem. You have to find quickly where the device resides. Okay. By the way, yes, this is another example of relational flow map. So here we saw a geographical point of view. Here we see more logical. So we have business critical service and users connecting to them. If this line becomes red, it means that one of the parameters, as a traffic, packet rate, runtime time, or server response time, is out of our thresholds. So, for instance, we can say that connections to our web server should not exceed 100 milliseconds runtime time. So that means if it's more, then it's too long, and we should know about it. Okay. We also integrate with a third-party device, with different proxy servers, with firewalls. First of all, to collect logs from them and correlate to the internal events, and second, to, for instance, block on the checkpoint firewall. So if you see that one of your hosts is infected with worm, you see this with StealthWatch, you can say that automatically block this host on the firewall or on the nearest router.
Why some lines are thick and others thin?
It's because of these rates. I think it's not clear.
Volume of traffic.
Volume of traffic, yes. So it's just, here it's some 100 packets per second, bits per second. Here it's.
So as you can see with this one, we have the going back to the second back-end system.
Yeah.
So we have this volume of traffic, and there's actually a low traffic alarm on the other server because so on that link, because suddenly there's not as much traffic as normal. So we're not just sending alarms on the anomalies that you tend to watch for. It's also things like, I need to understand why my application is not functioning correctly. And this is an example where one of those systems could be a physical system and the others could be back-end virtual systems. So I want to know between the communication between two VMs, if something has gone wrong in the configuration of that environment, is that causing an application issue? So this is where that user phones up and says, the network's slow. And that's the only information that guy is going to give you. So you need to understand from him, as a host in the network, which application is he communicating with, which systems are in the chain, and what are all of the elements that I need to see to determine whether it's a network issue, a server issue, an application issue, or just the user themselves being an idiot.
Okay, next I would like to show you one example of how we can use StealthWatch. Yes, right now we are in Vilnius, in Lithuania, so, but we are connected to Lankov's network. So by default, all the outside hosts that are not residing on our network, that we are not monitoring, are in their countries. So this is a database that is inside StealthWatch and gets renowned from time to time. So let's see what kind of information this costs. Okay, so these are IP addresses. This is the most active. I can assure you that this is my session from this laptop through Wi-Fi to the United States. I've checked that, and just let's see what does this mean. What can we see with? Okay, so I think this is the one. Nope. There are a few connections because Steve is also connected through the same NAT address to his mail. This is the best example. So here we see that application is StealthWatch. Guys Lekov defined this as a IP address plus special port. So we know that this application is StealthWatch. As the connection is encrypted, here we don't see application details much, but I'll show you when it's HTTP traffic, which is not encrypted, then we can see post and get requests clearly. So we can see how much traffic is going in both directions. We can see that which port is used, how many TCP connections. We can see this parameter called server response time. So how fast does our server respond to our incoming connections, and round trip time. By the way, it's very high right now. It used to be around 100 milliseconds in the morning when I just showed these presentations. So we see when did this connection started, how long it was active. So what we see here is one connection. In fact, StealthWatch keeps millions of these connections if you have them in your network. Because each connection actually takes just a few kilobytes of memory and storage. And you do not have a full session here, like a TCP dump, yes? But you have the most important information. Who connected whom, when, and on which ports. StealthWatch uses these so-called conversations or flows to detect scans or to detect just any other malicious activity in the network. Unfortunately, we are short of time, so I will not be able to show you all the alarms and talk about them in details, but yes, there are a lot of them. So this is also very important. For instance, if you have 10 routers in your network, you enable net flow from each of them to the central collector. It means that you can get 10 records about each connection. Lenko deduplicates this information and just shows as one conversation and all the interfaces it went through. So it's also very convenient for investigation forensics. Okay, so maybe you have questions because we're short of time. Just that I have time to answer.
What technology do you use in the background to store and later analyze such amount of data?
Okay, database is Vertica. Is this information? Yes, it's available. Vertica, it used to be a private company. Right now it's in a part of HP. So why this database? Because it works very well with flow data. You know, flow data is very specific. You can have a flow that is very short. And you can have a backup flow that lasts all night. Yes, and this Vertica copes very well with this kind of traffic. Platform is Linux. They've been 64 bits. So just, yeah. But here the main point is that when we talk about StealthWatch, we talk about solution. We don't want you to install operating system, to install database, then to try to tie this up. No, you receive a ready-to-go solution. All you have to do is put an IP address, put a DNS and gateway servers, and just you can start to work with it. So usually you spend more time defining your security policy and host groups inside the network. So this is very important. Yep. Maybe some other questions.
What is licensing?
Yes, a very good question. So if we talk about physical infrastructure, it's flows per second. So each 1,000 flows per second is an additional license. I can tell you that if you have a network with 2,000 users, it means that on average your users generate 2,000 flows per second, plus maybe, plus minus. If we talk about virtual environments, then number of physical hosts. Because length of flow sensor VE gets tied to a 6 physical server. It must not be motion. Yes. So other machines can be motion, but it must reside on one server. Yeah. Maybe some other questions.
Do you have demo license?
Well, in fact, demo licensing is not yet available.
Well, there's, the technology is, because it's all in one box, essentially, it's appliance-based. You can have a virtual client, so we can install them as a VM. we're able to do full demonstrations for you. If you have a requirement in your environment and you want to evaluate the technology, we can make evaluations available to you. So yes, we can do it that way, but it's not a one-click.
Yeah, it's not like just download and try.
Download and demonstrate, unfortunately.
And I think it will not be, because this is not where it's, let's say, this technology is clear enough, but you have to know a little bit before you can start. So usually it's better when you have a person who can explain you what you see. Just in a few sessions you will be able to do it yourself, but so that you don't lose too much time. Usually, for instance, in IPRO is I don't remember if I mentioned it. IPRO is exclusive partner of LANCOP in Baltics. So usually we provide our customers with full service. So installation, full support, hardware support, software support, and consultations. So usually I visit all my customers at least once a month if they don't have problems, and just tell them some new features of this technology, and just ask their questions. Maybe help them with tuning and just say best practices of using Stealthwatch. Yeah, this is how we work with Stealthwatch, and I think without it.
But anyway, I just want to add, if you want a demo, you just call us. Because we have a demo equipment, we can give it to you.
Yeah, actually,
and we can do the testing on your site, okay?
Yeah, actually we had demos in Lithuania already. Unfortunately, I cannot name customer. We usually do not name our customers if they explicitly do not allow us to do so. So if you can see on their website that they're using Stealthwatch, then we can tell you. But if they do not want us to say this information, we are not talking about it.
We have a lot of very sensitive customers.
Yeah. Like different military organizations and so on, so they don't like to talk about it. But for instance, Cisco, the security guys, they write freely in their blogs about using Stealthwatch, so you can read it yourself. Okay, maybe some other questions? You feel free to come to our stand if you need some additional demo, or maybe you have some questions. Feel free to come to Anna to get ticket, voucher for a book. And okay, thank you all for coming to this section. It was very nice.